Welcome back to this channel for practice problems for actuarial exams. We will look at a problem for exam MFE today. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. You have some information about resources I offer for studying for actuarial exams here. I direct the actuarial program at Illinois State University, and you can find information about it at smarturl.it/actuary. If you would like to make a donation to support our students, you can go to smarturl.it/help-ISU-actuary. Donations are tax-deductible to the extent allowed by law. Here's the problem for today. You are given the following information. The current price to buy one share of ABC stock is 100. The stock does not pay any dividends. The risk-free rate compounded continuously is 5%. European options on one share of ABC stock expiring in 1 year have the following prices. And we have strike prices of 90, 100, and 110. For 90, the call option price is 14.63. The put option price is 0.24. For 100 strike price, the call option price is 6.80, and put option price is 1.93. For a strike price of 110, the call option price is 2.17, and the put option price is 6.81. The butterfly spread on this stock has the following profit diagram. So note, this is not the payoff diagram, it's the profit diagram. Which of the following will not produce this profit diagram? Buy a 90 put, buy a 110 put, sell two 100 puts. Buy a 90 call, buy a 110 call, sell two 100 calls. Buy a 90 put, sell a 100 put, sell a 100 call, buy a 110 call. D, buy one share of the stock, buy a 90 call, buy a 110 put, sell two 100 puts. E, buy one share of the stock, buy a 90 put, buy a 110 call, sell two 100 calls. So I had mentioned to you already, you must pay attention to the fact that we're looking at profit, not payoff, and that means we have to include the cost of interest on any money that was used for the transaction. And I'm going through detailed stuff here. You don't really have to, because you could, you could actually, because this was a problem given in the real test, before things were computerized, you could guess that the answer is D, because you have to try every single answer before you finalize your answer choice, and then when that's the situation, before a computer picked the answers randomly, the answer was always D, because people always start with A, then do B, and get frustrated, try E, and get frustrated, go back and try C, and D is typically the last one that people try. But anyway, let's just look at the detail here and learn from it. That's the key message. So choice A is buy a 90 put, buy a 110 put, sell two 100 puts. The initial cost of that is $3.19, and at expiration that will amount to $3.35. That's a cost. At SP, the price of the underlying at expiration. The payoff of a 90 put at expiration is 90 minus S if S is less than 90 and 0 otherwise. The payoff of a 110 put is 110 minus S if S is less than 110 and 0 otherwise. The payoff of being short to 100 puts is 2S minus 200 if S is less than 100. And that's just minus the payoff of the put multiplied by 2. And 0 otherwise. Therefore, the profit of this position is what you get when you add up all of the items. For S less than 90, this ends up just being the constant, the cost of $3.35. For S between 90 and 110, this ends up being S minus 93.35. For S between 100 and 110, this ends up being 106.65 minus S. And for S more than 110, this ends up being negative 3.35. The graph of this is just like the figure given in the problem. Part B says buy a 90 call, buy a 110 call, sell 2 100 calls. Net initial cost is 320, and it accumulates to 3.36 at expiration. It's a cost again. Let S be the price of the underlying. The payoff of a 90 call at expiration is S minus 90 if S is more than 90 and 0 otherwise. The payoff of a 110 call is S minus 110 if S is more than 110 and 0 otherwise. And the payoff of being short 2 100 calls is 200 minus S if S is more than 100 and 0 otherwise. So the profit of this position is negative 3.36 if S is less than 90, S minus 93.36 if S is between 90 and 100, 106.64 minus S if S is between 100 and 110, and negative 3.36 if S is more than 110. This is basically the same answer as A minus a penny, essentially the same as A, so obviously the same pattern as the graph given in the problem. For part C, we buy a 90 put, sell a 100 put, sell a 100 call, buy a 110 call. This will have a net initial cost of negative 632. This amount will in turn accumulate to negative 6.64 at expiration. Now that's negative cost. So actually you get this money. The profit on this position is, again, you add up all the payoffs and this cash, and that ends up being negative 3.36 for S less than 90, S minus 93.36 for S between 90 and 100, 106.64 minus S if S is between 100 and 110, negative 3.36 for S more than 110. This is exactly the same result as in choice B, and it matches the graph in the problem. For part D, buy 1 share of the stock, buy a 90 call, buy a 100 put, sell 2 100 puts. So the payoff of a share of a stock, that's just this S value of the stock that we write. That's all we get for that. Net initial cost is 117.58. Accumulated with interest is 123.61. And the profit for this position is the payoff minus this cost of 123.61. That ends up being 2S minus 213.61 for S less than 90. Now remember, in the graph, you have a constant value for S less than 90. So just this part tells you immediately this is not the pattern that we see in the graph. And otherwise we have 3S minus 303.61 for S between 90 and 100, S minus 103.61 for S between 100 and 110, and then 2S minus 213.61 for S more than 110. Again, that's not a constant value that we have in the graph. So clearly this is not what the graph represents, and answer choice D is what we're looking for, because we're looking for the profit pattern that does not match the graph. Just to finalize the solution, we will look at answer E, where you buy 1 share of the stock, buy a 90 put, buy a 110 call, sell 2 100 calls. So net initial cost is 88.81. With interest, it's 93.36 at expiration. And the profit of the position, so notice that we have S, again, like in the previous one, but S cancels with 90 minus S for S less than 90, and we get a constant negative 3.36. Then we have S minus 93.36 for S between 90 and 100, and S minus 2S, so it's minus S, so 106.64 minus S for S between 100 and 110. And then S plus S minus 110 plus 200 minus 2S minus 93.36. That ends up being a constant negative 3.36 for S more than 110. This is the same profit as in the choice C, which matches the graph again. So the answer choice is D. Please remember this is copyrighted material, and the problem itself originates from Society of Actuaries, so it belongs to Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.